Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com, Network Time Protocol. Keeping clocks in sync focuses on one of the quiet yet critical services that enables accurate communication, secure transactions, and reliable logging across modern networks. Network Time Protocol, commonly known as NTP, synchronizes system clocks across all connected devices, ensuring that time-sensitive operations occur in harmony. Without synchronized time, authentication protocols can fail, logs from different devices become difficult to correlate, and scheduled operations may execute inconsistently. NTP keeps all systems aligned to a single, authoritative time source, which is essential for maintaining trust and order in both enterprise and internet-scale networks. The Network Plus certification includes NTP under both its services and infrastructure objectives, highlighting its role in keeping devices on the same clock cycle. Exam questions may require you to know the port NTP uses, understand how time is shared across systems, and identify the impacts of incorrect time synchronization. You might also be asked to troubleshoot scenarios where NTP has failed, or to recognize the differences between standard and simplified time protocols. Being comfortable with NTP's behavior and hierarchy is necessary for both configuration and exam success. Network Time Protocol is a long-standing protocol designed specifically for synchronizing time between systems over IP-based networks. It uses UDP port 123 and is built to provide both reliability and accuracy in timekeeping. The protocol allows computers to request the current time from a designated server, which in turn responds with precise timestamp information. This allows the requesting device to adjust its internal clock and remain synchronized with a larger, hierarchical system of time sources. NTP can be used across public and private networks, and it is supported by nearly every operating system and device class. Keeping clocks in sync across a network is not just a matter of neatness. It is essential for a range of network functions. Accurate timestamps allow for meaningful log analysis, enabling administrators to detect and investigate events in the correct order. Secure certificate validation also depends on consistent time between systems, as expiration dates are enforced based on system clocks. Furthermore, authentication protocols like Kerberos rely on tight synchronization, with even small deviations in time potentially causing logging failures. On the exam, this importance is often reflected in questions about failed authentication or inaccurate logs. NTP uses a hierarchical model of stratum levels to define the accuracy and trustworthiness of each time source. At the top is stratum 0, which includes extremely accurate timekeeping devices such as atomic clocks and GPS receivers. These devices are not directly connected to the network but are used to feed time into stratum 1's servers. A stratum 1 server is directly synchronized with a stratum 0 source and is considered a highly authoritative time server. Stratum 2 servers receive time from stratum 1 and the chain continues downward, with each level increasing in number and decreasing slightly in precision. Understanding stratum levels is crucial for interpreting how time is propagated through a network. A device that syncs with a stratum 1 server becomes a stratum 2 client. This structured approach allows networks to scale their time services while maintaining a consistent level of accuracy. Questions on the certification may present a scenario with multiple devices and ask which one is most authoritative based on its stratum level. Recognizing the hierarchy and how time flows through it is fundamental to configuring and managing time services correctly. Every NTP implementation involves devices acting as either servers or clients. The server's role is to provide accurate time to downstream systems, while the client adjusts its local clock based on the server's responses. In many networks, a server may also act as a client to a more accurate upstream source, creating a chain of time distribution. This hierarchical relationship ensures that all systems remain within an acceptable time range of each other. Clients typically poll their configured servers at set intervals, requesting the current time and calculating the difference between their clock and the server's clock. Clocks on most computing devices naturally drift over time due to minor inaccuracies in hardware timers. This drift can amount to several seconds or even minutes if left unchecked. NTP continuously corrects for this by gradually adjusting the system's clock based on its most recent polling data. These adjustments are made smoothly rather than all at once to avoid sudden time jumps that could disrupt ongoing processes. This concept of gradual correction helps prevent errors in time-sensitive applications and is frequently referenced in exam questions related to time accuracy and system behavior. Polling intervals are the defined times at which NTP clients request updates from their time sources. These intervals may be static or adjusted dynamically depending on the stability of the client's clock and the accuracy of the server. When the clock is stable and matches the server closely, the polling interval may increase to reduce network traffic. If discrepancies are large or the time changes frequently, the polling frequency increases to maintain precision. This behavior ensures efficient use of network resources while still achieving reliable synchronization. In some environments, administrators opt for Simple Network Time Protocol, or SNTP, as an alternative to full NTP. SNTP is a simplified version designed for devices with limited processing power or minimal timing requirements. It uses the same DDP port and basic messaging structure, but lacks the advanced algorithms and stratum-aware features of full NTP. Devices like routers, embedded controllers, and certain IoT systems often use SNTP to obtain reasonable synchronization without incurring the overhead of complete NTP functionality. Security is an important consideration when configuring NTP, as incorrect time data can disrupt essential services. Spoofed NTP servers may provide deliberately inaccurate time to trick systems into rejecting valid certificates or failing authentication checks. To prevent this, many systems support cryptographic authentication or restrict updates to trusted sources only. Monitoring for sudden or unexpected shifts in system time is another best practice, allowing administrators to catch possible attacks or misconfigurations before they escalate. Organizations must also choose between using external or internal time sources. Public NTP servers, often maintained by universities, government agencies, or nonprofits, provide reliable and accurate time for general use. However, enterprise environments frequently deploy their own internal Stratum 1 servers connected to GPS or atomic clocks. These internal sources reduce dependence on the internet, enhance control over time synchronization, and improve overall reliability. The exam may ask when to use public versus internal time sources, depending on network size and operational needs. For more cyber content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. Configuring network time protocol on network devices involves specifying one or more NTP servers, setting polling intervals, and enabling logging to track synchronization events. Most routers, switches, and firewalls support NTP configuration through their command line or graphical interfaces. Administrators typically assign a primary time source and one or more secondary sources for redundancy. Some implementations also support authentication features that verify the identity of the NTP server to prevent unauthorized or spoofed updates. These configurations help ensure that all network infrastructure remains synchronized and reliable. In a Windows Active Directory environment, NTP is vital for maintaining domain health. Domain controllers synchronize their clocks with a reliable time source, and all domain-joined clients rely on the domain hierarchy for time updates. Kerberos, the authentication protocol used in Active Directory, has strict time requirements and will reject login attempts if the client's clock differs significantly from the domain controller's clock. This makes accurate time not only a convenience but a necessity for authentication and system security. The certification exam may present scenarios where login issues are caused by time discrepancies in domain environments. Troubleshooting NTP issues involves checking both connectivity and accuracy. One of the first steps is to verify that the NTP server is reachable from the client using standard network diagnostic tools. Port 123 must be open between client and server, or time updates will fail. Comparing the client's current time with a known good external reference can also reveal inconsistencies. If multiple clients show different times, the source server may be the issue. Logs and diagnostic tools can help pinpoint where the failure occurs in the time synchronization chain. Administrators rely on several tools to evaluate NTP performance and status. The NTP queue command allows querying a server to see the peers it communicates with, the stratum level, and various statistics. NTP stat provides a high-level summary of synchronization status, such as whether the system is currently synchronized and how accurate the time is. Some network monitoring tools offer graphical views of clock drift over time, making it easier to spot trends or persistent deviations. These tools provide insight not just into whether time is set, but how well it remains in sync over time. Centralized time synchronization offers several operational and compliance benefits. When all systems log events based on the same clock, auditing becomes more accurate and effective. It also reduces the risk of configuration errors caused by systems operating with misaligned time zones or drifted clocks. Regulatory standards and legal investigations often require accurate timestamps, and a centralized NTP configuration helps meet those requirements. Questions on the exam may highlight the role of synchronized time in security, logging, or regulatory compliance. The public NTP Pool project is a globally distributed network of volunteer-maintained time servers available for general use. This system uses geographic load balancing to direct clients to nearby servers, improving speed and reliability. Many operating systems and network devices are pre-configured to use pool.ntp.org or similar addresses, making the service a widely used default. Despite being free and community-driven, the Pool project maintains a high standard of uptime and accuracy. On the exam, you may encounter references to the Pool project as a recommended public time source. Misconfigurations in time synchronization can lead to significant disruptions. If a system's clock is incorrect, it may fail to authenticate with other services, causing login issues or transaction errors. Asynchronous clocks across systems can make it nearly impossible to correlate logs or audit trails. Devices that lose power and reboot without battery-backed clocks may reset to a default date and time, breaking services that depend on current timestamps. Recognizing these impacts helps in identifying root causes during troubleshooting scenarios on the certification exam. Key topics related to network time protocol appear frequently on the certification. You may be asked to match NTP with its corresponding UDP port number, identify the correct stratum hierarchy for time distribution, or determine how time synchronization supports authentication protocols. Scenario questions often present symptoms such as failed logins, inaccurate logs, or time drift between systems, requiring you to identify NTP as the underlying issue. Understanding these principles enables accurate analysis and proper configuration of networked systems. Network time protocol plays a quiet but essential role in ensuring that systems across a network operate in coordination. By using a layered stratum system and standardized communication over port 123, NTP enables accurate and secure timekeeping. Whether supporting logging, authentication, or scheduling, synchronized time is vital for the integrity and reliability of network operations. A strong understanding of NTP's structure, function, and impact will support your progress as you prepare for deeper service management and system integration topics ahead. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.